So good morning, friends. So our first assignment is over. So these are the five questions that we have been asked. First question was advantage of modular programming. So we seen that there are mainly three advantages for modular programming. One is ease of use, reusability, and ease of maintenance. So if we are been dividing the problem into submodules, we can have all these three advantages. Second question was the difference between formal and the actual parameter. The parameter passed to a function are called the actual parameter. The parameter received by the function are called the formal parameter. Next question was difference between function declaration and function definition. Function declaration indicate what function is, and function definition indicate what function does. Okay. Next question was what is modular programming? Modular programming is the process of subdividing a computer program into separate subprograms. So that is modular programming. Next question, when we do modular programming, we have written it like that. Some programs might have thousands or millions of lines, and to manage such programs it becomes quite difficult as there might be too many of the syntax errors or logical errors present in the program. So in that case it's better to have a modular program. So still now when we are approaching a problem, we will just try to solve the problem. From after studying this modular programming, what we have to do is, if we have a problem in our hand, is it possible to divide the problem into subproblem? We'll check that whether it is possible to divide the problem. If it is possible, then we will go for modular programming because it provides a lot of advantages. So if the problem is in our hand can be divided into subproblem, we will go for modular programming. So in our problem, I have given an assignment in that we have been asking for finding prime number, Armstrong number. So a lot of things are there. So it can be divided. So surely we have to go for modular programming. Next, we will go for the programming assignment. First question was we want to perform swapping. So program to swap two numbers using functions. So we want to swap two numbers using functions. So first of all, I have used the stdio.h header file. Then this is a swap function. I have declared that function has been declared void swap int means it's a swap function. It's having two arguments of type integer and it's not returning anything. So normally, okay. Next is the main function. The main function, I am reading two numbers, and the two numbers are being read to a and b variables. Okay, so next line I'm going to print that value. Numbers are what numbers I have entered, that will be printed here. After that, I'm performing the swap function a comma b. This is the actual argument. A and b is the actual argument. It has been passed to the function. Okay, in the function I'm again printing the number passed to the swap function. So I'm again confirming that these are the two numbers. It has been passed to the function. Then performing the swap function. Swap function, how to perform swap function? We will use another variable temp. First a value will be passed to temp, and a is now free and b value is been passed to a, then temp value is been passed to b. That means value is been swapped. After that I'm just printing that value numbers after swap is of a and b, that is a and b values are been changed. But when we are printing again the main, what we can see is the value is not being changed because actual value is being changed in the formal arguments only. This a and b is a formal argument, and this a and b is the actual argument. I have purposefully specified used the same variable a and b in both formal and the actual arguments. But these two variables are completely different. They will have different memory locations. In the earlier program, when we are writing the PowerPoint, I have specified two different variables. It's not necessary to have two different variables. We can use the same variable, but these two same variables are different. This a and b will have a memory location maybe 1000 and 2000, and this a and b will be have another memory location maybe 4,000 and 5,000. So they are completely different. We have seen that it's totally, while performing the swap function, only the formal arguments are being changed. Actual argument content is still there. That's the thing in this program. So I hope it's clear. We will run this program. I'm using Windows. So I will use the GCC compiler, GCC swap.c. It has been compiled. Then I want to execute. I am using Windows. That's why I'm using a.exe. Enter two numbers. I'm asked to enter two numbers. I'm entering 4 and 5. 4 and 5 are the numbers. Numbers are 4 and 5. Numbers passed to the swap function are 4 and 5. Number after swap is 5 and 4. But number after function call is again form 4, 5. It's not been changed in the main. User is not changing the user. If you assume that void main is the user end and the function we are asking for swapping, still the user value is not being changed, only the formal arguments is being changed. Next we will go for the second problem. So second problem, we have to perform several operations. We have to perform 4 operations. We want to find whether a number is prime, Armstrong, even or odd, and palindrome. So you are being asked four operations of a functions. So when we see that this is a problem, it can be divided, can be subdivided into submodules. And these if we subdivide, it's easy to handle. We can reuse. If a particular user want only to find prime number, we can still use the same program to perform that. If you're writing the whole program without using modular programming, it's not possible to give such use, because ease of use will be, it will not provide that much ease. Okay, so when we are performing like this, it become very easy, and we can reuse the components. So that's the advantage. So we will go for the program. So this is std.h has been used. Then mat.h is used because I'm using prime number. So I will be checking up to square root of the number. So that's why I'm using mat.h. So I'm declaring the functions, function declaration, prime function. Purposefully I have written I have written the function like this. Prime function will have an argument int and it is returning int. This function, after completing, after checking whether a number is prime or not, it will return an integer value. Same thing for Armstrong, even or odd, and palindrome. This program, sorry. In this program, what we are trying to do, assume, is that user is at the main. So user is working at the main. He want to perform the following operations. He want to check whether the number entered is a prime, Armstrong, or even or odd, palindrome. That's the requirements. So I'm assuming that I'm the user. I'm working in the main. Okay. So we will see the main function int p. Then ch is there for entering the choice. Then a flag value is there, flag 0, then result. So I'm going to use a do while function. Do while I want to repeat the process. So first the user is asking, enter the choice. What is the requirement of the user? Whether I have to find prime number, Armstrong, even or odd, or palindrome. So I'm asking that. Okay, if I'm entering 1, that means the user want to find a prime number, check whether the number is prime. If it is true, it's Armstrong, 3 is odd, even or odd, and 4 is palindrome. So, okay, that's the technique. So after entering the choice, user has been asked to enter the number. So according to the number, I'm using a switch case to have options. If the choice is 1, the prime function will be called. Look at the function. So this is a prime function. This is having an input argument and passing the number to the prime function. And after performing the operation, it will return a value. And based on the value, user can state that whether the number is prime or not. Why I have written like this is that if the requirement is different, I want to perform some other operations after checking a number is prime or not. So according to my requirement, I can rewrite the code here itself. The prime function is just a function that will perform check whether a number is prime or not and will return a value. Based on the value, user can do any action. Suppose action is to perform the, if the number is prime, I have to perform square root. If the number is not prime, I have to perform cube root. That's the requirement. Same thing we can do here. That's why I have written like this. So prime p, it will the return value will be the result. The result will be according to the result value. The number it will be. I am printing whether the number is prime or not. So result value, I'm assuming it as 1 or 0. The function will return either 1 or 0. If it's 1, it's a prime number. 0, it's not a prime number. Same thing for Armstrong. If the choice is 2, then I have to go for the case 2. Case 2 case, and Armstrong function will be called. Armstrong function, if the number is Armstrong, the function will return 1. Then the user will print it's an Armstrong number, and otherwise it's not an Armstrong number. Same thing if the case is 3, case 3, then I will go for the even or odd case P. So if the result is 1, I am assuming it's as even number, and if it is 0, it's an odd number. So last case, palindrome, I'm checking whether if it's a palindrome, it will return 1, otherwise it will return 0. So if the flag is 1, that means if any other options, if any other than these 4 options, if I'm entering any other options, I should break. That's why in the default case I have specified that specified flag value 1 and break. If the flag is 0, the while loop will be breaking. The do while loop will break when the flag value is 1. Initially the flag value is 0 here. Flag value is set as 0. So in do while loop, do will check while condition while flag not equal to 0. Flag not equal to 1. It's not equal to 1, 0. So it will again loop, and until it reaches the flag value 1, it will break. So that's the program of the user end. So what's the prime function do? Same thing that you know already. I'm checking that prime number. So a number will be passed. I want to check whether the number is prime or not. What I will do, I will perform an iteration from 2 to square root of that number. Square root of that number. I will find out the mode value. Suppose 5 is the number, 5 mod 2 equal to 0. If it is equal to 0, we can stop there. Otherwise, it should repeat that until the number. I'm checking that flag equal to 0, flag equal to 1. I will explain this once more. If the number is 5, I equal to 2, I is less than square root of 5, that is 2 point something, so it's less than or equal to 2 point something. Then we will reach here 5 mod 2, 5 mod 2 equal to not equal to 0, not equal to 0, it's not equal to 0, then I will be incremented, I will be 3, 3 is less than square root of, it's not, it's false, statement will come, it will return 5, 5 is a prime number. In the case of 4, 4 will be 4 mod I, 4 mod 2 equal to 0, so flag will be set it, so it will return 0, so that's a program, it's a prime number. So even or odd, if number mod 2 equal to 0, it returns 1, otherwise return 0. This is a simple function. Then Armstrong, so Armstrong means cube root, 153 is an Armstrong number. This 1 cube plus 5 cube plus 3 cube is that number itself. So what we do is we will find the digits. So first of all, I have the number 153. I will be performing the operation until the number reaches 0. So I am copying the number 153 to temp. Okay, so temp not 153 is not equal to 0. Then we will find temp mod 10. Temp mod 10 will return 3. So the 3 will be 3 into 3 into 3, that is 27. 27 is stored in Armstrong number. So 27, then I am dividing that 153 by 10, that's 15. We will get 15. 15 not equal to 0. 15 not equal to 0. Then 15 mod 10 is again 5. Then we will find out the cube root. 5 cube plus 5 cube, 5 cube. Then that will be added with the Armstrong. Again the next number 1. 1 will be reached. 1 mod 10 is again 1 cube plus 1 cube plus 1 cube. Total Armstrong will be Armstrong, the variable Armstrong will have that 153 itself. If if both are equal, then it's an Armstrong number, otherwise it's not an Armstrong number. That's the thing. Palindrome, the same thing, only thing is I will reverse that number. So I will reverse the number, then I will check whether the number and the reverse number is same. If it's same, we can say it's an palindrome. So we'll just run the program. So I have to use -lm because I have to be using sqrt. So I'm compiling that gcc using that, then a.exe I'm compiling. So enter the choice. The choice 1, I have to enter the number I'm checking. Okay, 4. The number is not a prime. 1, again choice is 5. Number is prime. So 2, I'm entering the number 153. 153 is an Armstrong number. It's an Armstrong number. And again 2, I'm giving another option 134. 134 is not an Armstrong number. 3, third option, if even or odd. 2 is an even number. Then 3, 5 is an odd number. 4, I'm giving it as 121. 121 is a palindrome number. Another number 134. Fourth option 134. It's not an Armstrong. It's not a. So it's the program. I hope all of you